Hi everyone and welcome back to the channel. Today we have got something special in store for you if you are gearing up for the AWS Security Specialty Certification exam. In this video I will be covering the topics and questions that will help you pass the SCS-C02 certification exam. I have compiled a 45 practice questions to get you prepped and primed for the success on the AWS Security Specialty Certification exam. So, if you are ready to ace the AWS certification exam and elevate your career to new heights, make sure to hit that like button, subscribe to the channel, and ring the notification bell so that you don't miss any future content. So, gear up and let's dive into the success. Question number 1. A company is migrating one of its legacy systems from an on-premises data center to AWS. The application server will run on AWS, but the database must remain in the on-premises data center for compliance reasons. The database is sensitive to network latency. Additionally, the data that travels between the on-premises data center and AWS must have IPsec encryption. Which combination of AWS solutions will meet these requirements? Choose two. And the options are option A, AWS site-to-site VPN, option B, AWS Direct Connect, option C, AWS VPN Cloud Hub, option D, VPC pairing, and option E, NAT Gateway, that is Network Address Translation Gateway. So we have to choose two correct options, and these correct options are number 1 is option A, AWS site-to-site VPN. So this will ensure our secure connection between the on-premises and the AWS. This IPsec encryption requirement will be met by the AWS site-to-site VPN. And the second correct option is AWS Direct Connect. So the network latency requirement will be fulfilled by the AWS Direct Connect. And this is how this looks in visual. So this is, let's suppose, the customer data center, and this is the AWS cloud. This is the direct connect. So using the direct connect between the on-premises data center and the AWS will have low network latency, and this is the site-to-site IPsec VPN, which will ensure the required security that is asked in this question. And this is the explanation. So the company requires secure low latency connectivity between the on-premises data center and AWS with IPsec encryption. Here's how these options meet the requirements. Number 1, AWS site-to-site VPN, which is option A, enables a secure connection or IPsec between an on-premises data center and AWS, fulfilling the requirement for encrypted data transmission. And AWS Direct Connect, option B, provides a dedicated network connection with lower latency than standard internet connection, which helps minimize latency for the sensitive database. Although Direct Connect alone does not include encryption, it can be combined with AWS site-to-site VPN to add IPsec encryption over the dedicated connection. Question number 2. A security engineer is configuring a new website that is named example.com. The security engineer wants to secure communications with the website by requiring users to connect to example.com through HTTPS. Which of the following is a valid option for storing SSL/TLS certificates? And the options are option A, custom SSL certificate that is stored in AWS Key Management Service, that is AWS KMS. Option B, default SSL certificate that is stored in Amazon CloudFront. Option C, custom SSL certificate that is stored in AWS Certificate Manager, that is ACM. And option D, default SSL certificate that is stored in Amazon S3. And the correct option is option C, custom SSL certificate that is stored in AWS Certificate Manager. And this is the explanation. So to secure communication with a website using HTTPS, an SSL/TLS certificate is needed. AWS Certificate Manager, that is ACM, is the appropriate service for storing and managing custom SSL/TLS certificates in AWS. It provides a secure, scalable way to handle SSL and TLS certificates for use with various AWS services, including Amazon CloudFront and Elastic Load Balancing. Question number 3. A company has an application that uses dozens of Amazon DynamoDB tables to store data. Auditor finds that the tables do not comply with the company's data protection policy. The company's retention policy states that all data must be backed up twice each month, once at midnight on the 15th day of the month and again at midnight on the 25th day of the month. The company must retain the backup for 3 months. Which combination of steps should a security engineer take to meet these requirements? Choose 2 options. And the options are: option A, use the DynamoDB on-demand backup capacity to create a backup plan. Configure a life cycle policy to expire backups after 3 months. Option B, use AWS Data Sync to create a backup plan. Add a backup rule that includes a retention period of 3 months. Option C, use AWS Backup to create a backup plan. Add a backup rule that includes a retention period of 3 months. Option D, set the backup frequency by using a cron schedule expression. Assign each DynamoDB table to the backup plan. And option E, set the backup frequency by using a rate schedule expression. Assign each DynamoDB table to the backup plan. So we have to choose 2 correct options. The first correct option is option C. Use AWS Backup to create a backup plan. Add a backup rule that includes a retention period of 3 months. And the second correct option is option D. Set the backup frequency by using a cron schedule expression. Assign each DynamoDB table to the backup plan. And the explanation for the correct options are: so, to meet the company's data retention policy, which requires specific backup schedules and retention periods for Amazon DynamoDB, a security engineer can use AWS Backup. AWS Backup supports DynamoDB and enables centralized backup management, including the ability to define schedules and retention policies. Option C is correct because AWS Backup can create a backup plan with rules specifying a 3-month retention period. Option D is correct because AWS Backup supports cron expressions to set specific backup times, such as midnight on the 15th and 25th of each month. This allows backups to be scheduled according to the company's policy. Question number 4. Company A has an AWS account that is named Account A. Company A recently acquired Company B, which has an AWS account that is named Account B. Company B stores its files in an Amazon S3 bucket. The administrators need to give a user from account a full access to the S3 bucket in Account B. After the administrators adjust the IAM permissions, that is Identity and Access Management permissions, for the user in Account A to access the S3 bucket in Account B, the user still cannot access any files in the S3 bucket. Which solution will resolve the issue? And the options are: option A, in Account B, create a bucket ACL to allow the users from Account A to access the S3 bucket in Account B. Option B, in Account B, create an object ACL to allow the user from Account A to access all the objects in the S3 bucket in Account B. Option C, an account B, create a bucket policy to allow the user from account A to access the S3 bucket in account B. And option D, an account B, create a user policy to allow the user from account A to access the S3 bucket in account B. And the correct option is option C. In account B, create a bucket policy to allow the user from account A to access the S3 bucket in account B. And the explanation is, so when granting cross-account access to an Amazon S3 bucket, a bucket policy in the target account, that is account B, is generally the recommended solution. This bucket policy can specify the permissions for a user in a different AWS account, in this case account A, to access the bucket and its objects. Even if the identity and access management permissions in account A are configured, the bucket in account B must also allow access to complete the cross-account setup. Option C is correct because a bucket policy in account B can explicitly grant access to the user from account A, enabling them to access both the bucket and its objects if the policy specifies full access. Question number 5. A company is designing a multi-account structure for its development teams. The company is using AWS organizations and AWS IAM Identity Center, that is AWS Single Sign-On. The company must implement a solution so that the development teams can use only specific AWS regions, and so that each AWS account allows access to only specific AWS services. Which solution will meet these requirements with the least operational overhead? And the options are option A, use IAM Identity Center to set up service-linked roles with IAM policy statements that include the condition, resource, and not action element to allow access to only the regions and services that are needed. Option B, deactivate AWS Security Token Service, that is AWS STS, in regions that the developers are not allowed to use. Option C, create SCPs that include the condition, resource, and not action elements to allow access to only the regions and services that are needed. And option D, for each AWS account, create tailored identity-based policies for IAM Identity Center. Use statements that include the condition, resource, and not action elements to allow access to only the regions and services that are needed. And the correct option is option C, create SPCs that include the condition, resource, and not action elements to allow access to only the regions and services that are needed. And the explanation is, so when managing access across multiple accounts in an AWS organization, service control policies, that are SCPs, are the recommended approach for enforcing organization-wide access control. SCPs provide a centralized way to restrict access to specific AWS services and regions across all member accounts in the organization. By using the condition, resource, and not action elements, the company can precisely control which regions and services are accessible, fulfilling the requirements with minimal operational overhead. Option C, SCPs, is correct because SCPs are designed for organization-level access control. They apply across all accounts within the AWS organization, making them an efficient solution for restricting both services and region with a single configuration. Question number 6. A security engineer creates an Amazon S3 bucket policy that denies access to all users. A few days later, the security engineer adds an additional statement to the bucket policy to allow read-only access to one other employee. Even after updating the policy, the employee still receives an access denied message. What is the likely cause of this access denial? And the options are option A, the ACL in the bucket needs to be updated. Option B, the IAM policy does not allow the user to access the bucket. Option C, it takes a few minutes for a bucket policy to take effect. And option D, the allow permission is being overridden by the deny. And the correct option is option D, the allow permission is being overridden by the deny. So in AWS, explicit deny statements take precedence over allow statements. Since original bucket policy denies access to all users, this explicit deny will override any subsequent allow statements, including the new statement intended to allow read-only access for one specific employee. As a result, the employee will receive an access denied message. Question number 7. A company is using Amazon Massey AWS Firewall Manager, Amazon Inspector, and AWS Shield Advanced in its AWS account. The company wants to receive alerts if DDoS attack occurs against the account. Which solution will meet this requirement? In the options are option A, use Massey to detect an active DDoS event. Create Amazon CloudWatch alarms that respond to Massey findings. Option B, use Amazon Inspector to review resources and invoke Amazon CloudWatch alarms for any resources that are vulnerable to DDoS attacks. Option C, create an Amazon CloudWatch alarm that monitors Firewall Manager metrics for an active DDoS event. And option D, create an Amazon CloudWatch alarm that monitors Shield Advanced metrics for an active DDoS event. And the correct option is option D, create an Amazon CloudWatch alarm that monitors Shield Advanced metrics for an active DDoS event. And the explanation is AWS Shield Advanced provides dedicated DDoS protection and includes metrics that can be monitored through Amazon CloudWatch. By creating an Amazon CloudWatch alarm for Shield Advanced metrics, the company can receive immediate alerts when a DDoS attack is detected, which meets the requirement for timely notifications. Question number 8. What are the most secure ways to protect the AWS account root user of a recently opened AWS account? Choose two options. And the options are option A, use the AWS account root user access keys instead of the AWS management console. Option B, enable multi-factor authentication for the AWS IAM users with the administrator access managed policy attached to them. Option C, use AWS KMS to encrypt all AWS account root user and AWS IAM access keys and set automatic rotation to 30 days. Option D, do not create access keys for the AWS account root user. Instead, create AWS IAM users. And option E, enable multi-factor authentication for the AWS account root user. And the correct options are option D, do not create access keys for the AWS account root user. Instead, create AWS IAM user. And the second correct option is option E, enable multi-factor authentication for the AWS account root user. And the explanation is option D, it's highly recommended to avoid using the root account for daily operations. Instead, create IAM users with appropriate permissions for tasks, as this limits root user exposure. And option E, enabling multi-factor authentication for the root account adds a critical layer of security, making it harder for unauthorized users to access the account even if they have the root password. Question number 9. A company is hosting a web application on Amazon EC2 instances behind an application load balancer, that is ALB. The application has become the target of a DOS attack. Application logging shows that requests are coming from a small number of client IP addresses, but the addresses change regularly. The company needs to block the malicious traffic with a solution that requires the least amount of ongoing effort. Which solution meets these requirements? And the options are option A, create an AWS web application firewall rate-based rule and attach it to the ALB. Option B, update the security group that is attached to the ALB to block the attacking IP addresses. Option C, update the ALB subnets network ACL to block the attacking client IP addresses. And option D, create an AWS web application firewall rate-based rule and attach it to the security group of the EC2 instances. And the correct option is option A, create an AWS web application firewall rate-based rule and attach it to the ALB. And the explanation is that AWS WAF, that is Web Application Firewall, allows you to set rate-based rules which can automatically detect and block IP addresses that are sending an unusually high rate of request. Attaching the rule to the ALB ensures that the malicious traffic is blocked at the load balancer level, which is the most efficient point for handling such threats and requires minimal ongoing management. Question number 10. A company has enabled Amazon Guard Duty in all AWS regions as part of its security monitoring strategy. In one of its VPCs, the company hosts an Amazon EC2 instance that works as an FTP server. A high number of clients from multiple locations contact the FTP server. Guard Duty identifies this activity as a brute force attack because of the high number of connections that happen every hour. The company has flagged the finding as a false positive, but Guard Duty continues to raise the issue. A security engineer must improve the signal to noise ratio without compromising the company's visibility of potential anomalous behavior. Which solution will meet these requirements? And the options are option A, disable the FTP rule in Guard Duty in the region where the FTP server is deployed. Option B, add the FTP server to a trusted IP list. Deploy the list to Guard Duty to stop receiving the notifications. Option C, create a suppression rule in Guard Duty to filter findings by automatically archiving new findings that match the specified criteria. And option D, create an AWS Lambda function that has the appropriate permissions to delete the finding whenever a new occurrence is reported. And the correct option is option C, create a suppression rule in Guard Duty to filter findings by automatically achieving new findings that match the specified criteria. And the explanation is suppression rules in Guard Duty allow you to filter out specific findings based on criteria such as the instance ID or finding type. By creating a suppression rule, the company can automatically archive the specific findings related to the FTP server expected activity. This approach keeps the Guard Duty service active for other important findings and maintain visibility without unnecessary noise. Question number 11. A company's security engineer has been tasked with restricting a contractor's IAM account access to the company's Amazon EC2 console without providing access to any other AWS services. The contractor's IAM account must not be able to gain access to any other AWS service, even if the IAM account is assigned additional permissions based on the IAM group membership. What should the security engineer do to meet these requirements? And the options are option A, create an inline IAM user policy that allows for Amazon EC2 access for the contractor's IAM user. Option B, create an IAM permissions boundary policy that allows Amazon EC to access, associate the contractor's IAM account with the IAM permissions boundary policy. Option C, create an IAM group with an attached policy that allows for Amazon EC to access, associate the contractor's IAM account with the IAM group. And option D, create an IAM role that allows for EC2 and explicitly denies all other services. Instruct the contractor to always assume this role. And the correct option is option B. Create an IAM permissions boundary policy that allows Amazon EC to access. Associate the contractor's IAM account with the IAM permissions boundary policy. And the explanation is, so a permissions boundary limits the maximum permissions that an IAM account or IAM users can receive. By setting a permissions boundary that only allows Amazon EC to access, the security engineers ensures that even if the contractor's account is assigned additional permissions through IAM group or other means, the account will not gain access to services outside EC2. This approach meets the requirement of restricting the contractor to EC2 only access effectively. Question number 12. A company manages multiple AWS accounts using AWS organizations. The company's security team notices that some member accounts are not sending AWS CloudTrail logs to a centralized Amazon S3 logging bucket. The security team wants to ensure there is at least one trail configured for all existing accounts and for any account that is created in the future. Which set of actions should the security team implement to accomplish this? And the options are option A, create a new trail and configure it to send CloudTrail logs to Amazon S3. Use Amazon Event Bridge to send notification if a trail is deleted or stopped. Option B, deploy an AWS Lambda function in every account to check if there is an existing trail and create a new trail if needed. Option C, edit the existing trail in the organization's management account and apply it to the organization. And option D, create an SCP to deny the CloudTrail delete, static, and CloudTrail stop static actions. Apply the SCP to all accounts. And the correct option is option C, edit the existing trail in the organization's management account and apply it to the organization. And the explanation is, by configuring an organization trail in the AWS organization management account, CloudTrail will automatically log activities from all member accounts and send the logs to the specified Amazon S3 bucket. This approach ensures that any new accounts created in the organization will inherit this trail automatically, simplifying management and ensuring centralized logging. Question number 13. A company recently had a security audit in which the auditors identified multiple potential threats. These potential threats can cause usage pattern changes such as a DNS access peak, abnormal instance traffic, abnormal network interface traffic, and unusual Amazon S3 API calls. The threats can come from different sources and can occur at any time. The company needs to implement a solution to continuously monitor its system and identify all these incoming threats in near real time. Which solution will meet these requirements? Options are option A, enable AWS CloudTrail logs, VPC flow logs, and DNS logs. Use Amazon CloudWatch logs to manage these logs from a centralized account. Option B, enable AWS CloudTrail logs, VPC flow logs, and DNS logs. Use Amazon Messy to monitor these logs from a centralized account. Option C, Enable Amazon Guard Duty from a centralized account. Use Guard Duty to manage AWS Cloud Trail logs, VPC flow logs, and DNS logs. And option D, enable Amazon Inspector from a centralized account. Use Amazon Inspector to manage AWS Cloud Trail logs, VPC flow logs, and DNS logs. And the correct option is option C. So the correct option is option C. Enable Amazon Guard Duty from a centralized account. Use Guard Duty to manage AWS Cloud Trail logs, VPC flow logs, and DNS logs. And the explanation is, so Amazon Guard Duty is specifically designed to continuously monitor for suspicious activity and potential threats by analyzing cloud trail logs, VPC flow logs, and DNS logs in near real time. Guard Duty uses machine learning, anomaly detection, and integrated threat intelligence to detect abnormal patterns and security threats, making it the ideal solution for the described use case. Question number 14. A security engineer is using AWS organizations and wants to optimize SCPs. The security engineer needs to ensure that SCPs conform to best practices. Which approach should the security engineer take to meet this requirement? And the options are option A, use AWS Identity and Access Management Access Analyzer to analyze the policies. View the findings from policy validation checks. Option B, review AWS Trusted Advisor checks for all accounts in the organization. Option C, set up AWS Audit Manager, run an assessment for all AWS regions for all accounts. And option D, ensure that Amazon Inspector agents are installed on all Amazon EC2 instances in all accounts. And the correct option is option A, use AWS IAM Access Analyzer to analyze the policies, view the findings from policy validation checks. And the explanation is, AWS Identity and Access Management Access Analyzer includes policy validation checks that identify potential issues, best practices, and potential security gaps in policies, including SCPs. This tool is specifically designed for validating and optimizing policies by providing actionable feedback, making it the ideal solution for ensuring SCPs conform to best practices. Question number 15. A startup company is using a single AWS account that has resources in a single AWS region. A security engineer configures an AWS cloud trail in the same region to deliver log files to an Amazon S3 bucket by using the AWS CLI. Because of expansion, the company adds resources in multiple regions. The security engineer notices that the logs from the new regions are not reaching the S3 bucket. What should the security engineer do to fix this issue with the least amount of operational overhead? And the options are option A, create a new cloud trail, select the new regions where the company added resources. Option B, change the S3 bucket to receive notification to track all actions from all regions. Option C, create a new cloud trail that applies to all regions. And option D, change the existing cloud trail so that it applies to all regions. And the correct option is option D, change the existing cloud trail so that it applies to all regions. And the explanation is, modifying the existing cloud trail to apply to all regions ensures that logs from any new or existing regions are automatically included and sent to the S3 bucket. This approach minimizes operational overhead by avoiding the need to create or manage multiple trails for each region. Question number 16. A company's public application load balancer, that is ALB, recently experienced a distributed denial of service attack. To mitigate this issue, the company deployed Amazon CloudFront in front of the ALB so that users would not directly access the Amazon EC2 instance behind the ALB. The company discovered that some traffic is still coming directly into the ALB and is still being handled by the EC2 instances. Which combination of steps should the company take to ensure that the EC2 instances will receive traffic only from CloudFront? Choose two options, and the options are: option A, configure CloudFront to add a cache key policy to allow a custom HTTP header that CloudFront sends to the ALB. Option B, configure CloudFront to add a custom HTTP header to requests that CloudFront sends to the ALB. Option C, configure the ALB to forward only requests that contain the custom HTTP header. Option D, configure the ALB and CloudFront to use the X-forwarded FAR header to check client IP addresses. And option E, configure the ALB and CloudFront to use the same X509 certificate that is generated by the AWS Certificate Manager. And the correct options are: option B, configure CloudFront to add a custom HTTP header to requests that CloudFront sends to the ALB. And option C, configure the ALB to forward only requests that contain the custom HTTP header. And the explanation is: for option B, adding a custom HTTP header to request from CloudFront allows the ALB to distinguish between traffic originating from CloudFront and traffic coming directly to the ALB. And the second option, option C, is configuring the ALB to only forward requests containing this custom header ensures that only traffic from CloudFront will reach the EC2 instances. This setup effectively blocks any direct access to the ALB by requiring that incoming requests have the header, which only CloudFront will add. Question number 17. A company discovers a billing anomaly in its AWS account. A security consultant investigates the anomaly and discovers that an employee who left the company 30 days ago still has access to the account. The company has not monitored account activity in the past. The security consultant needs to determine which resources have been deployed or reconfigured by the employee as quickly as possible. Which solution will meet these requirements? And the options are: option A, in AWS Cost Explorer, filter chart data to display results from the past 30 days. Export the results to a data table. Group the data table by resource. Option B, use AWS Cost Anomaly Detection to create a cost monitor. Access the detection history. Set the time frame to last 30 days. In the search area, choose the service category. Option C, in AWS CloudTrail, filter the event history to display results from the past 30 days. Create an Amazon Athena table that contains the data. Partition the table by event source. And option D, use AWS Audit Manager to create an assessment for the past 30 days. Apply a usage-based framework to the assessment. Configure the assessment to assess by resource. And the correct option is option C. In AWS CloudTrail, filter the event history to display results from the past 30 days. Create an Amazon Athena table that contains the data. Partition the table by event source. And the explanation is: AWS CloudTrail records all account activity, including API calls and changes to resources, which will provide detailed information about any deployments or configurations made by former employee. By filtering the CloudTrail event history for the past 30 days, a security consultant can quickly identify any actions taken by the employee. Creating an Amazon Athena table and partitioning by event source enables efficient querying and analysis of this data. Question number 18. A security engineer is checking an AWS CloudFormation template for vulnerabilities. The security engineer finds a parameter that has a default value that exposes an application's API key in plain text. The parameter is referred several times throughout the template. The security engineer must replace the parameter while maintaining the ability to reference the value in the template. Which solution will meet these requirements in the most secure way? And the options are option A, store the API key value as a secure string parameter in AWS System Manager Parameter Store. In the template, replace all references to the value with resolve SSM my SSM parameter name : 1. Option B, store the API key value in AWS Secrets Manager. In the template, replace all references to the value with resolve : secrets managers : my secret id : secret string. And option C, store the API key value in Amazon DynamoDB. In the template, replace all references to the value with resolve : DynamoDB : my table name : my primary key. And option D is store the API key value in a new Amazon S3 bucket. In the template, replace all references to the value with resolve : S3 : my bucket name : my object name. And the correct option is option B, store the API key value in AWS Secrets Manager. In the template, replace all references to the value with resolve : secrets manager : my secret id : secret string. And the explanation is that AWS Secrets Manager is specifically designed for managing sensitive information such as API keys, passwords, and tokens. It provides built-in support for automatic rotation of secrets and integrates well with AWS services. By using the resolve : secrets manager : my secret id : secret string syntax, you can securely reference the API key in your CloudFormation template without exposing it in plain text. Question number 19. A company's AWS CloudTrail logs are all centrally stored in an Amazon S3 bucket. The security team controls the company's AWS account. The security team must prevent unauthorized access and tampering of the CloudTrail logs. Which combination of steps should the security team take? Choose three options, and the options are option A, configure server-side encryption with AWS KMS manage encryption keys, that is SAC-KMS. Option B, compress log files with secure gzip. Option C, create an Amazon Event Bridge rule to notify the security team of any modifications or CloudTrail log files. Option D, implement least privilege access to the S3 bucket by configuring a bucket policy. Option E, configure CloudTrail logs file integrity validation. And option F, configure access analyzer for S3. So we have to choose three correct options, and the first correct option is option A, configure server-side encryption with AWS KMS manage encryption keys. The second correct option is option D, implement least privilege access to the S3 bucket by configuring a bucket policy. And the third and last correct option is option E, configure CloudTrail logs file integrity validation. And the explanation for all these options is configure server-side encryption with AWS KMS manage encryption keys. This ensures that log files are encrypted at rest, protecting them from unauthorized access. Option D, implement least privilege access to the S3 bucket by configuring a bucket policy. By applying a strict bucket policy, the security team can control who has access to the logs, ensuring that only authorized personnel can view or modify them. And option E, configure CloudTrail logs file integrity validation. This feature allows CloudTrail to create a hash of log files and store it in an Amazon S3 bucket. This way, the integrity of the logs can be verified, ensuring that they have not been tampered with. Question number 20. A company has several workloads running on AWS. Employees are required to authenticate using on-premises ADFS, that is AD Federated Services, and SSO to access the AWS Management Console. Developers migrated an existing legacy web application to an Amazon EC2 instance. Employees need to access this application from anywhere on the internet, but currently there is no authentication system built into the application. How should the security engineer implement employee-only access to this system without changing the application? And the options are: option A, place the application behind an application load balancer. Use Amazon Cognito as authentication for ALB. Define as SAML-based Amazon Cognito user pool and connect it to ADFS. Option B, implement AWS IAM Identity Center, that is AWS single sign-on in the management account, and link it to ADFS as an identity provider. Define the EC2 instance as a managed resource, then apply an IAM policy on the resource. Option C, define an Amazon Cognito identity pool, then install the connector on the Active Directory server. Use the Amazon Cognito SDK on the application instance to authenticate the employees using their Active Directory username and password. And option D, create an AWS Lambda custom authorizer as the authenticator for a reverse proxy on Amazon EC2. Ensure the security group on Amazon EC2 only allows access from the Lambda function. And the correct option is option A, place the application behind an application load balancer ALB. Use Amazon Cognito as authentication for the ALB. Define SML-based Amazon Cognito user pool and connect it to ADFS, that is Active Directory Federated Services. And the explanation is, so number one, place the application behind an ALB. By using an application load balancer, you can manage incoming traffic and enhance security. Number two, use Amazon Cognito for authentication. Amazon Cognito provides a user authentication service that can integrate with existing identity providers like ADFS through SAML. This allows employees to authenticate using their corporate credential without modifying existing application. And number three, define SML-based Amazon Cognito user pool. This setup will allow seamless authentication for users across ADFS, providing a secure and manageable way to control access to the application. Question number 21. Company has a web browser in the AWS cloud. Web server. A company has a web server in the AWS cloud. The company will store the content for the web server in an Amazon S3 bucket. A security engineer must use an Amazon CloudFront distribution to speed up delivery of the content. None of the files can be publicly accessible from the S3 bucket directly. Which solution will meet these requirements? And the options are: option A, configure the permissions on the individual file in the S3 bucket so that only the CloudFront distribution has access to them. Option B, create an origin access control. Associate the OAC or origin access control with the CloudFront distribution. Configure the S3 bucket permission so that only the OAC can access the files in the S3 bucket. Option C, create an S3 role in AWS Identity and Access Management. Allow only the cloud front distribution to assume the role to access the files in S3 bucket. And option D, create an S3 bucket policy that uses only the cloud front distribution ID as the principal and the Amazon resource name as the target. And the correct option is option B. Create an Origin Access Control OAC. Associate the OAC with the cloud front distribution. Configure the S3 bucket permission so that only the OAC can access the files in the S3 bucket. And the explanation is Origin Access Control OAC. So this feature allows you to create a controlled access path between CloudFront and your S3 bucket. By using OAC, you can restrict access to your S3 bucket so that only the specified CloudFront distribution can retrieve these files. S3 bucket permissions. After creating the OAC and associating it with your CloudFront distribution, you configure the S3 bucket's permissions to allow access only to the OAC. This effectively makes the contents of the S3 bucket private while still allowing CloudFront to serve the files. Question number 22. A company is storing data in Amazon S3 Glacier. The security engineer implemented a new vault lock policy for 10 terabyte of data and called initiate vault lock operation 12 hours ago. The audit team identified a typo in the policy that is allowing unintended access to the vault. What is the most cost-effective way to correct this? And the options are option A, call the abort vault lock operation, update the policy, call the initiate vault lock operation again. Option B, copy the vault data to a new S3 bucket, delete the vault, create a new vault with the data. Option C, update the policy to keep the vault lock in place. And option D, update the policy, call initiate vault lock operation again to apply the new policy. And the correct option is option A, call the abort vault lock operation, update the policy, call the initiate vault lock operation again. And the explanation is, so number one, vault lock policy. Once you initiate a vault lock policy using the initiate vault lock operation, the policy is in a locked state and you cannot modify it until you abort the lock. Number two, abort and update. By calling the abort vault lock operation, you can cancel the current vault lock request. After aborting it, you can update the policy to correct the typo and then call initiate vault lock again to apply the new policy. Cost effectiveness. This option does not require copying data or creating new resources, which would incur additional cost. It effectively corrects the policy while minimizing expenses. Question number 23. A company wants to control access to its AWS resources by using identities and groups that are identified in its existing Microsoft Active Directory. What must the company create in its AWS account to map permissions for AWS services to Active Directory user attributes? And the options are option A, AWS IAM groups, option B, AWS IAM user, option C, AWS IAM roles, and option D, AWS IAM access keys. And the correct option is option C, AWS IAM roles. And the explanation is IAM roles allow you to define permissions for AWS services based on attributes from your Active Directory. By integrating AWS with Microsoft Active Directory using AWS Single Sign-On or AWS Directory Service, you can assign IAM roles to Active Directory users and groups. This enables users to assume roles and gain the necessary permissions to access AWS resources. Using IAM roles in conjunction with your Active Directory simplifies permissions management and ensures that access control aligns with your organization's existing identity infrastructure. Question number 24. An application is currently secured using network access control lists and security groups. Web servers are located in public subnets behind an application load balancer. Application servers are located in private subnets. How can edge security be enhanced to safeguard the Amazon EC2 instances against attack? Choose two options. Option A, configure the application's EC2 instances to use NET gateways for all inbound traffic. NET is network address translation. Option B, move the web servers to private subnets without public IP addresses. Option C, configure AWS WAF, that is Web Application Firewall, to provide DDoS attack protection for the ALB. Option D, require all inbound network traffic to route through a Bayesian host in the private subnet. And option E, require all inbound and outbound network traffic to route through an AWS Direct Connect connection. And the correct options are option B, move the web servers to private subnets without public IP addresses. And option C, configure AWS Web Application Firewall to provide DDoS attack protection for the ALB. And the explanation is, so to enhance edge security and safeguard the Amazon EC2 instances against attacks, the following two options should be considered. Option C, configure AWS WAF to provide DDoS attack protection for the ALB. AWS WAF, that is Web Application Firewall, can help protect your application from common web exploits that could be used to compromise your application, such as SQL injection and cross-site scripting. It can also provide late limiting and help mitigate DDoS attacks by filtering out malicious traffic before it reaches your application load balancer. Option B, move the web server to private subnets without public IP addresses. By placing web servers in private subnets and removing their public IP addresses, you reduces their exposure to the internet. Access to these servers can then be controlled through the application load balancer, further enhancing security by limiting direct access to the web servers. Question number 25. A security engineer has been tasked with configuring outbound mail through simple mail services, that is SCS, and requires compliance with current TLS standard. TLS is Transport Layer Security. The mail application should be configured to connect to which of the following endpoints and corresponding ports? Option A, email.us-is-1.amazonaws.com or port 8080. Option B, email-pop3 us-east.amazonaws.com or port 995. Option C, email-smtp.us-east-1 amazonaws.com or port 587. And option D, email-imap.us-east-1 amazonaws.com or port 993. And the correct option is option C, email-smtp.us-east-1.amazonaws.com or port 587. And the explanation is, so email-smtp.us-east-1.amazonaws.com is the SMTP endpoint for SCS and it supports sending emails. Port 587 is the standard port for SMTP, that is Simple Mail Transfer Protocol, submissions or TLS, making it the appropriate choice for secure email sending. The other options listed are either related to different email protocols such as IMAP and POP3 or use non-standard ports for SMTP. Question number 26. A company has a customer master key with imported key materials. Company policy requires that all encryption keys must be rotated every year. What can be done to implement the above policy? Option A. Enable automatic key rotation annually for the CMK. Option B. Use AWS command line interface to create an AWS Lambda function to rotate the existing CMK annually. Option C. Import new key material to the existing CMK and manually rotate the CMK. And option D. Create a new CMK, import new key material to it, and point the key alias to the new CMK. And the correct option is option D. Create a new CMK, import new key material to it, and point the key alias to the new CMK. And the explanation is security. So this approach ensures that the old key material is immediately replaced with new, stronger key material, minimizing the potential exposure of sensitive data. Efficiency. Pointing the key alias to the new CMK allows for a seamless transition without requiring any changes to applications or systems that rely on the CMK. And compliance. This method aligns with the company's policy of annual key rotation and ensures compliance with security best practices. Question number 27. A water utility company uses a number of Amazon EC2 instances to manage updates to a fleet of 2000 Internet of Things field devices that monitor water quality. These devices each have unique access credentials. An operational safety policy requires that access to specific credentials is independently auditable. What is the most cost-effective way to manage the storage of credentials? In the options are option A. Use AWS System Manager to store the credential as secure string parameter. Secure by using an AWS KMS key. Option B. Use AWS Key Management System to store a master key, which is used to encrypt the credentials. The encrypted credentials are stored in an Amazon RDS instance. Option C. Use AWS Secret Manager to store the credentials. And option D. Store the credentials in a JSON file on Amazon S3 with server-side encryption. And the correct option is option A. Use AWS System Manager to store the credential as secure strings parameter. Secure by using an AWS KMS key. So the explanation is AWS System Manager parameter store allows you to store configuration data and secrets securely. Using secure strings ensures that the credentials are encrypted, with AWS KMS key providing an additional layer of security. Auditable access. AWS System Manager offers built-in auditing capabilities through AWS CloudTrail, enabling you to track access and modifications to parameters, which meets the operational safety policy requirement for independent auditability. Cost effectiveness. Parameters store is generally more cost effective than using services specifically designed for secret management, such as AWS Secrets Manager, especially when dealing with a large number of credentials like the 2000 Internet of Things devices. Question number 28. A security engineer must design a solution that enables the incident response team to audit for changes to a user's identity and access management permissions in the case of a security incident. How can this be accomplished? And the options are option A. Use AWS config to review the IAM policy assigned to users before and after the incident. Option B, run the generate credential report via the AWS CLI and copy the output to Amazon S3 daily for auditing purposes. Option C, copy AWS Cloud Formation templates to S3 and audit for changes from the template. And option D, use Amazon EC2 System Manager to deploy images and review AWS CloudTrail logs for changes. And the correct option is option A, use AWS config to review the IAM policy assigned to users before and after the incident. AWS config is a service that provides detailed visibility into the configuration of your AWS resources, including IAM policies. It continuously monitors and records your AWS resource configuration and allows you to automate the evaluation of recorded configurations against desired configurations. By using AWS config, you can track changes to IAM policies assigned to users, view historical configurations, and evaluate compliance over time. This capability is crucial for auditing changes during a security incident. Question number 29. A company has complex connectivity rules governing ingress, egress, and communication between Amazon EC2 instances. The rules are so complex that they cannot be implemented within the limits of the maximum number of security groups and network access control lists, that is, network ACLs. What mechanism will allow the company to implement all required network rules without incurring additional cost? And the options are option A, configure AWS Web Application Firewall rules to implement the required rules. Option B, use the operating system built-in host-based firewall to implement the required rules. Option C, use a NAT gateway to control ingress and egress according to the requirements. And option D, launch an EC2-based firewall product from the AWS marketplace and implement the required rules in that product. And the correct option is option B, use the operating system built-in host-based firewall to implement the required rules. So host-based firewall can be configured directly on each EC2 instance to manage inbound and outbound traffic. This approach allows you to set very granular rules that may exceed the limits of security groups and network ACLs. Using the built-in firewall, for example, IP tables or Linux or Windows firewall on Windows, allows you to create specific rules tailored to your application and connectivity needs without incurring additional costs associated with AWS services or third-party solutions. Question number 30. A company requires that IP packet data can be inspected for invalid or malicious content. Which of the following approaches achieve these requirements? Choose two options. Option A, configure a proxy solution on Amazon EC2 and route all outbound VPC traffic through it. Perform inspection within proxy software on the EC2 instance. Option B, configure the host-based agent on each EC2 instance within VPC. Perform inspection within the host-based agent. Option C, enable VPC flow logs for all subnets in the VPC. Perform inspection from the flow log data within Amazon CloudWatch logs. Option D, configure elastic load balancing access logs. Perform inspection from the log data within the ELB access log files. And option E, configure the CloudWatch logs agent on each EC2 instance within the VPC. Perform inspection from the log data within CloudWatch logs. And the correct options are option A, configure a proxy solution on Amazon EC2 and route all outbound VPC traffic through it. Perform inspection within proxy software on the EC2 instance. And option B, configure the host-based agent on each EC2 instance within the VPC. Perform inspection within the host-based agent. So the explanation is option A allows for detailed inspection of traffic as it passes through the proxy. By routing all outbound traffic through the EC2 instance with proxy software, the company can analyze the content of the packets and identify any malicious or invalid data effectively. Option B involves installing a host-based agent on each EC2 instance, which can inspect outgoing and incoming traffic for malicious content. This approach provides real-time monitoring and inspection of packet data directly at the source, enabling immediate detection of potential threats. Question number 31. An organization has a system in AWS that allows a large number of remote workers to submit data files. File sizes vary from a few kilobytes to several megabytes. A recent audit highlighted a concern that data files are not encrypted while in transit over untrusted networks. Which solution would remediate the audit finding while minimizing the effort required? And the options are option A. Upload an SSL certificate to IAM, that is Identity and Access Management, and configure Amazon CloudFront with the passphrase for the private key. Option B. Call kms.encrypt in the client, passing in the data file contents, and call kms.decrypt server side. Option C. Use AWS Certificate Manager to provision a certificate on an elastic load balancing in front of the web services servers. And option D. Create a new VPC with an Amazon VPC VPN endpoint and update the web services DNS record. And the correct option is option C. Use AWS Certificate Manager to provision a certificate on an elastic load balancing in front of the web services servers. And the explanation is option C allows you to easily provision an SSL/TLS certificate using AWS Certificate Manager and associate it with an elastic load balancer. This setup enables HTTPS for the web service, encrypting all data in transit between the remote workers and the servers. This solution is relatively straightforward to implement as ACM handles certificate management and renewal, reducing operational overhead. Question number 32. Which options for the use of AWS Key Management Service, that is KMS, supports key management best practices that focus on minimizing the potential scope of data exposed by possible future key compromise? And the options are option A. Use KMS automatic key rotation to replace the master key and use this new master key for future encryption operations without re-encrypting previously encrypted data. Option B. Generate a new customer master key, re-encrypt all existing data with the new CMK and use it for all future encryption operations. Option C. Change the CMK alias every 90 days and update key calling applications with the new key alias. And option D. Change the CMK permissions to ensure that individuals who can provision keys are not the same individual who can use the keys. And the correct option is option B. Generate a new customer key, that is CMK, re-encrypt all existing data with the new CMK and use it for all future encryption operations. And the explanation is option B is the best practice because it involves creating a new CMK for encrypting data. By re-encrypting existing data with the new key, you ensure that if a key is compromised, the exposure is limited only to data encrypted with that specific key. This effectively minimizes the potential impact of a key compromise since the older key can be decommissioned, isolating data that is still protected by it. Question number 33. A company's database developer has just migrated an Amazon RDS database credential to be stored and managed by AWS Secrets Manager. The developer has also enabled rotation of the credential within the Secret Manager console and set the rotation to change every 30 days. After a short period of time, a number of existing applications have failed with authentication errors. What is the most likely cause of the authentication errors? And the options are option A. Migrating the credentials to RDS requires that all access come through request to the Secrets Manager. Option B. Enabling rotation in Secrets Manager causes the secrets to rotate immediately and applications are using the earlier credential. Option C. The Secrets Manager IAM policy does not allow access to the RDS database. And option D. The Secret Manager IAM policy does not allow access for the applications. And the correct option is option B. Enabling rotation in Secrets Manager causes the secret to rotate immediately and the applications are using the earlier credential. And the explanation is when rotation is enabled in AWS Secrets Manager, it can lead to the secret being rotated immediately. If the applications that rely on the database credential are not updated to fetch the latest version of the credential of the rotation after the rotation occurs, they will continue to use the old credential which is no longer valid. This mismatch can cause authentication errors as applications attempt to authenticate with outdated credentials. Question number 34. A security engineer launches two Amazon EC2 instances in the same Amazon VPC but in separate availability zones. Each instance has a public IP address and is able to connect to external hosts on the internet. The two instances are able to communicate with each other by using their private IP addresses, but they are not able to communicate with each other when using their public IP addresses. Which action should the security engineer take to allow communication over the public IP addresses? And the options are option A. Associate the instances to the same security groups. Option B. Add 0/0 to the egress rule of the instance security groups. Option C. Add the instance IDs to the ingress rules of the instance security groups. And option D. Add the public IP addresses to the ingress rules of the instance security groups. And the correct option is option D. Add the public IP addresses to the ingress rules of the instance security groups. By default, security groups in the AWS are stateful, meaning that if you allow traffic in one direction, that is ingress, the response traffic is allowed regardless of the egress rule. However, for two instances to communicate over their public IP addresses, you need to specifically allow incoming traffic from each instance public IP address in their respective security group rules. Question number 35. The Information Technology Department has stopped using classic load balancers and switched to application load balancers to save costs. After the switch, some users on older devices are no longer able to connect to the website. What is causing these situations? The options are option A. Application load balancers do not support older web browsers. Option B. The perfect forward secrecy settings are not configured correctly. Option C. The intermediate certificate is installed within the application load balancer. And option D. The cipher suits on the application load balancers are blocking connections. And the correct option is option D. The cipher suits on the application load balancers are blocking connections. So, cipher suit compatibility. Application load balancers support a variety of cipher suits, but older devices and browsers might not support the newer, more secure cipher suits. This can lead to connection failures. security versus compatibility. While using strong cipher suits is important for security, it's crucial to balance security with compatibility. To resolve this issue, you can configure compatible cipher suits, review the cipher suit configuration on your application load balancer, and enable a wide range of cipher suits that are compatible with older devices and browsers. Consider a hybrid approach. If you need to support a diverse range of clients, consider using a combination of application load balancers and classic load balancers. Classic load balancers offer more flexibility in terms of cipher suit support. Question number 36. A security team is responsible for reviewing AWS API call activity in the cloud environment for security violations. These events must be recorded and retained in a centralized location for both current and future AWS regions. What is the simplest way to meet these requirements? And the options are option A. Enable AWS Trusted Advisor security checks in the AWS console and report all security incidents for all regions. Option B. Enable AWS CloudTrail by creating individual trails for each region and specify a single Amazon S3 bucket to receive log files for later analysis. Option C. Enable AWS CloudTrail by creating a new trail and applying the trail to all regions. Specify a single Amazon S3 bucket as the storage location. And option D, enable Amazon CloudWatch logging for all AWS services across all regions and aggregate them to a single Amazon S3 bucket for later analysis. And the correct option is option C, enable AWS CloudTrail by creating a new trail and applying the trail to all regions. Specify a single Amazon S3 bucket as the storage location. And the explanation is centralized logging. This approach centralizes all API call activity logs into a single S3 bucket, making it easier to review and analyze. Regional coverage. By applying the trail to all regions, you ensure that API calls from all regions are captured and stored in the same location. Security focus. CloudTrail is specifically designed for monitoring API calls, making it a suitable tool for security analysis. Question number 37. An organization policy states that all encryption keys must be automatically rotated every 12 months. Which AWS key management service key type should be used to meet this requirement? Option A, AWS Managed Customer Master Key, that is CMK. Option B, Customer Managed CMK with AWS Generated Key Material. Option C, Customer Managed CMK with Imported Key Material. And option D, AWS Managed Data Key. And the correct option is option A, AWS Managed Customer Master Key. And the explanation is automatic rotation. AWS Managed CMK support automatic key rotation, which means the key material is automatically replaced with new key material at a specific interval. Security. AWS manages the key material, ensuring strong security practices and reducing the risk of human error. Compliance. Automatic rotation helps organizations comply with security regulations that require regular key rotation. Question number 38. A security engineer received an AWS abuse notice listing EC2 instance IDs that are reportedly abusing other hosts. Which action should the engineer take based on this situation? Choose three options. And the options are option A, use AWS artifact to capture an exact image of the state of each instance. Option B, create EBS snapshots of each of the volumes attached to the compromised instances. Option C, capture a memory dump. Option D, log into each instance with administrative credential to start the instance. To restart the instance. Option E, revoke all network ingress and egress except for two from a forensic workstation. And option F, run auto recovery for Amazon EC2. And the correct options are option B, create EBS snapshots of each of the volumes attached to the compromised instances. Option C, capture a memory dump. And option E, revoke all network ingress and egress except for from a forensic workstation. And the explanation is, or option B, create EBS snapshot of each of the volume attached to the compromised instances. This ensures that you have a backup of the data stored on the EBS volume before taking further actions. Option C, capture a memory dump. This provides a valuable information about the running processes and the state of the system at the point of the incident, which is essential for forensic analysis. And option E, revoke all network ingress and egress except for form a forensic workstation. This action helps to contain the potential damage by isolating the compromised instances from the rest of the network while still allowing access for forensic investigation. Question number 39. A security engineer is trying to determine whether the encryption keys used in an AWS service are in compliance with certain regulatory standards. Which of the following actions should the engineer perform to get further guidance? Option A, read the AWS customer agreement. Option B, use AWS Artifact to access AWS compliance reports. Option C, post the question on the AWS discussion forums. And option D, run AWS config and evaluate the configuration outputs. And the correct option is option B, use AWS Artifact to access AWS compliance reports. And the explanation is AWS Artifact provides on-demand access to AWS compliance documentation and reports, including information on encryption standards and practices. This resource can help the engineer verify compliance with specific regulatory requirements. Question number 40. The development team receives an error message each time the team members attempt to encrypt or decrypt a secure string parameter from the SSM. Parameter store by using an AWS KMS Customer Managed Key (CMK). Which CMK related issue could be responsible? Choose two options. Option A, the CMK specified in the application does not exist. Option B, the CMK specified in the application is currently in use. Option C, the CMK specified in the application is using the CMK key ID instead of CMK Amazon resource name. Option D, the CMK specified in the application is not enabled. And option E, the CMK specified in the application is using an alias. And the correct options are option A, the CMK specified in the application does not exist. And option D, the CMK specified in the application is not enabled. And the explanation is the error message that the development team is receiving when attempting to encrypt or decrypt a secure string parameter from the SSM parameter store using an AWS KMS Customer Managed Key could be due to the following CMK related issues. A, the CMK specified in the application does not exist. If the specified CMK does not exist in the account or region, the encryption-decryption operation will fail. And D, the CMK specified in the application is not enabled. If the CMK is disabled, it cannot be used for encryption or decryption operation, which would lead to errors when the development team attempts to use it. Question number 41. An application has been written that publishes custom metrics to Amazon CloudWatch. Recently, identity and access management changes have been made on the account and the metrics are no longer being reported. Which of the following is the best permissive solution that will allow the metrics to be delivered? And the options are option A, add a statement to the IAM policy used by the application to allow logs, put log events and logs, create log stream. Option B, modify the identity and access management role used by the application by adding the CloudWatch full access managed policy. Option C, add a statement to the IAM policy used by the application to allow CloudWatch put metric data. And option D, add a trust relationship to the IAM role used by the application for cloudwatch.amazonaws.com. And the correct option is option C, add a statement to the IAM policy used by the application to allow CloudWatch put metric data. And the explanation is least privilege. So this option grants only the specific permission required for the application to publish metrics, that is CloudWatch put metric data. It avoids granting unnecessary access to other CloudWatch actions and focus on functionality. It directly addresses the issue of publishing metrics without granting broader access to logs or other resources. Question number 42. A developer's laptop was stolen. The laptop was not encrypted and it contained the SSH key used to access multiple Amazon EC2 instances. A security engineer has verified that the key has not been used and has blocked port 22 to all EC2 instances while developing a response plan. How can the security engineer further protect currently running instances? And the options are option A, delete the key pair key from the EC2 console, then create a new key pair. Option B, use the modify-instance-attribute API to change the key on any EC2 instance that is using the key. Option C, use the EC2 run command to modify the authorized keys file on any EC2 instance that is using the key. And option D, update the key pair in any AMI used to launch the EC2 instances, then restart the EC2 instances. And the correct option is option C, use the EC2 run command to modify the authorized keys file on any EC2 instance that is using the key. And the explanation is, so this option has the immediate impact. This approach immediately revokes the compromised key from running instances without requiring a full instance restart. Minimal downtime. By modifying the authorized key file, you avoid the potential downtime associated with terminating and relaunching instances. And targeted solution. You can selectively apply this solution to instances that were using the compromised key, minimizing the impact on other instances. Question number 43. The security engineer for a mobile game has to implement a method to authenticate users so that they can save their progress. Because most of the users are part of the same OpenID Connect compatible social media website, the security engineer would like to use that as the identity provider. Which solution is the simplest way to allow the authentication of users using their social media incidents, using their social media identities? And the options are option A, Amazon Cognito, option B, Assume Role with Web Identity API, option C, Amazon Cloud Directory, and option D, Active Directory Connector. And the correct option is option A, Amazon Cognito. And the explanation is, so this option has user pools. Cognito user pools provide a fully managed user directory that can be easily integrated with social identity providers like Facebook, Google, and more. Simplified authentication. Cognito handles the authentication process, including users sign up, sign in, and password management, making it easy to implement. And seamless integration. Cognito seamlessly integrates with your mobile application, allowing users to sign in with their social media credentials. Additional features include Cognito offers additional features like user data storage, multi-factor authentication, and custom authentication flows, making it a comprehensive solution for user authentication and authorization. Question number 44. The InfoSec team has mandated that in the future only approved Amazon machine images, that is AMIs, can be used. How can the information security team ensure compliance with this mandate? Option A. Terminate all Amazon EC2 instances and relaunch them with approved AMIs. Option B. Page all running instances by using AWS Systems Manager. Option C. Deploy AWS config rules and check all running instances for compliance. And option D. Define a metric filter in Amazon CloudWatch logs to verify compliance. And the correct option is option C. Deploy AWS config rules and check all running instances for compliance. And the explanation is continuous monitoring. So AWS config rules allow you to set up continuous monitoring of your resources, including EC2 instances. Customizable rules. You can create custom rules to check if the AMI ID of each instance matches a list of approved AMIs. Automated enforcement. AWS config can trigger automated actions such as sending notifications or invoking remediation scripts when non-compliant instances are detected. And historical analysis. AWS config stores historical configuration data, allowing you to analyze past configuration and identify potential compliance issues. Question number 45. A pharmaceutical company has digitized versions of historical prescriptions stored on premises. The company would like to move these prescriptions to AWS and perform analytics on the data in them. Any operation with this data requires that the data be encrypted in transit and at rest. Which application flow would meet the data protection requirements on AWS? Option A. Digitized files, Amazon Kinesis Data Analytics. Option B. Digitized files to Amazon Kinesis Data Firehouse, to Amazon S3, to Amazon Athena. Option C. Digitized files, Amazon Kinesis Data Streams, Kinesis Client Library Consumer, Amazon S3 and Athena. And option D. Digitized files, Amazon Kinesis Data Firehouse and Amazon Elasticsearch. And the correct option is option B. Digitized files, Amazon Kinesis Data Firehouse, Amazon S3 and Amazon Athena. And the explanation is Amazon Kinesis Data Firehouse. So this service can capture and transport the digitized files to Amazon S3. It provides built-in encryption for data in transit. You can also enable server-side encryption on the S3 bucket to ensure the data is encrypted at rest. Amazon S3. When data is stored in S3, you can enable encryption like SAC S3 or SAC KMS to ensure that data is encrypted at rest. Amazon Athena. This service allows you to run SQL queries directly against the data stored in S3. It integrates well with the S3 and can query the encrypted data seamlessly. So that's all for this video. I hope this video have been of benefit to you people. So please like and subscribe and stay tuned for the next video. Thank you and bye.